Bismillahirrahmanirrahim. Welcome to my YouTube channel Geeky Math. Today I am going to share solution of physics grade 9th Cantab publisher.
Chapter number 7. Topic Work, Energy and Power. Multiple choice questions. Question number 1. Which of the following best defines work done by a force on an object? Option A is the distance moved by the object in the direction of the force. Option B is the energy transferred to the object. Option C is the product of the force applied to the object and the time it is applied. Option D is the product of the force applied to the object and the distance moved in the direction of the force. So the correct option is D, the product of the force applied to the object and the distance moved in the direction of the force. The explanation of this question is, this definition is consistent with the formula of work. Work equals to force into distance, where force is applied force and the distance is the displacement of the object in the direction of the force. Question number 2. What does energy refer to in a physical context? Option A, the speed of an object. Option B, the ability of an object to do work. Option C, the mass of an object. Option D, the temperature of an object. So the correct option is B, the ability of an object to do work. Question number 3. Which of the following scenarios is an example of an object possessing energy? Option A, a compressed spring. Option B, a book laying on a table. Option C, a parked car. Option D, both A and C. So the correct option D, both A and C. Explanation of this question is, a compressed spring has potential energy stored in its compressed state, while a parked car has kinetic energy although currently at rest due to its mass and its potential to move. Question number 4. Kinetic energy can be visualized on a kinematic graph as the area under which of the following curve? Option A, velocity time graph. Option B, acceleration time graph. Option C, force distance graph. Option D, displacement time graph. So the correct option is A, velocity time graph. Its explanation is, the area under a velocity time graph represents the displacement of an object. Since kinetic energy is related to the square of velocity, the area under the velocity time graph, which represents the average velocity over time, can be used to visualize kinetic energy. Question number 5. The gravitational potential energy of an object depends on its option A, speed. Option B, mass and height above the ground. Option C, volume. Option D, density. So the correct option is mass and height above the ground. The gravitational potential energy of an object is calculated using formula PE equals to mgh. P is the potential energy, m is the mass of the object, g is the acceleration due to gravity, h is the height above the ground. The potential energy depends only on the mass and height of the object, not on its speed, volume or density. Question number 6. When a ball is thrown straight up into the air at the highest point. Option A, kinetic energy is maximum. Option and potential energy is 0. Option B, kinetic energy is 0 and potential energy is maximum. Option C, both kinetic and potential energy are equal. Option D, total energy is 0. So the correct option is B, kinetic energy is 0 and the potential energy is maximum. At the highest point of its trajectory, the ball has stopped moving upwards and is about to start falling back down. Therefore, its kinetic energy, which is related to its motion, is zero. However, due to its position above the ground, it has maximum potential energy, which is stored energy due to its position in a gravitational field. Question number 7. In a pendulum, energy conversion from kinetic to potential energy occurs at which point of its swing? Option A, at the lowest point. Option B, at the highest point. Option C, midway between the highest and lowest point. Option D, throughout the swing. So the correct option is at the highest point. In a pendulum, the energy conversion from kinetic to potential energy occurs at the highest point of its swing. At the point the pendulum has momentarily stopped moving and is about to change direction. At this instant, its kinetic energy is zero and its potential energy is at its maximum due to its height above the lowest point of its swing. Question number 8. During the photosynthesis, plants convert option A, kinetic energy into chemical energy, option B, chemical energy into kinetic energy, option C, solar energy into chemical energy, option D, mechanical energy into nuclear energy. So the correct option is solar energy into chemical energy. During photosynthesis, plants use solar energy to convert carbon dioxide and water into glucose, a type of sugar, and oxygen. This process is a conversion of solar energy into chemical energy. Question number 9. When you rub your hands together on a cold day, the mechanical work done is primarily converted into option A, chemical energy, option B, elastic energy, option C, kinetic energy, and option D, thermal energy. So the correct option is thermal energy. When you rub your hands together, the mechanical work you do is primarily converted into thermal energy, which is the energy associated with the movement of molecules. This is why your hands feel warm after rubbing them together. Question number 10. Hydroelectric energy is generated by converting which type of energy into electrical energy? Option A, chemical, B, kinetic, C, potential, D, thermal. So the correct option is potential. Hydroelectric energy is generated by harnessing the potential energy stored in water at a higher elevation. This potential energy is converted into kinetic energy as the water flows downhill, turning turbines and generating electricity. Question number 11. Which of the following is a renewable energy source? So the correct option is coal, B is oil, C is wind. Question number 11. Which of the following is a renewable energy source? Option A, coal, option B, oil, option C, wind, option D, natural gas. So the correct option is option C, wind. Wind is a renewable energy source because it is constantly replenished by the sun's heat. Wind turbines can convert the kinetic energy of the wind into electrical energy. Question number 12. One disadvantage of solar power compared to fossil fuels is that solar power. Option A is not renewable. Option B produces greenhouse gases. Option C is not always available. Option D is more expensive to harness. So the correct option is C, is not always available. One disadvantage of solar power is that it is not always available, especially during cloudy days or at night. This can make it difficult to rely solely on solar power for energy needs.
Question number 13. In any practical machine, the efficiency is less than 100% because option A, machines require constantly input of energy. Option B, some energy is always converted to non-useful forms. Option C, energy can be created. Option D, the laws of physics allow for some exceptions. So the correct option is B. Some energy is always converted to non-useful forms. In any practical machine, some energy is always lost due to factors such as friction, heat, or sound. This means that the output energy is always less than the input energy, resulting in an efficiency of less than 100%. Question number 14. In a system where 500 joule of energy is input and the system has an efficiency of 80%, then the output useful work of the system is option A 400 joule, option B 100 joule, option C 300 joule, option D 200 joule. So the correct option is 400 joule. Let's see its solution. Efficiency equals to output work divided by input energy multiplied by 100%. So the efficiency is given, that is 0.80 equals to output work divided by input energy, that is 500 joule into 100%. By solving this equation, you got 400 joule. So the question number 15, a box is Question number 15. A box is dragged across a floor with a constant force. If the force is doubled and the distance remains the same, how does the work done change? Option A, it remains the same. Option B, it doubles. Option C, it quadruples. Option D, it halves. So the correct option is it doubles. Work is calculated as force multiplied by distance. If the force is doubled while the distance remains the same, the work done will also double. Question number 16. The energy stored within the nucleus of an atom is known as option A kinetic energy, option B nuclear energy, option C electrostatic energy, option D thermal energy. So the correct option is nuclear energy. The energy stored within the nucleus of an atom is known as nuclear energy. This energy is released during nucleus reactions such as nuclear fission and fusion. Question number 17. What happens to the kinetic energy of an object if its mass is halved and its speed remains constant? Option A, it doubles. Option B, it remains the same. Option C, it is halved. Option D, it is quartered. So the correct option is C, it is halved. Kinetic energy is calculated as 1 by 2 into mass into velocity square. If the mass is halved while the velocity remains constant, the kinetic energy will also be halved. Question number 18. Which of the following is a renewable resource that relies on the cycle of water? Option A coal, option B oil, option C biomass, option D tidal energy. So the correct option is D tidal energy. Tidal energy is a renewable resource that relies on the gravitational pull of the moon and the sun on the earth's oceans. This gravitational pull causes tides which can be harnessed to generate electricity. Short questions. Question number 1. Why is it impossible for any practical machine to achieve 100% efficiency? Answer is It's impossible for practical machines to achieve 100% efficiency due to energy losses. These losses typically occur in the form of heat, friction, or sound. For example, when a car engine burns fuel, some of the energy is converted into mechanical energy to move the wheels, but a significant amount is lost as heat. Question number 2. How does the conservation of energy principle apply to a roller coaster moving from the highest to the lowest point? Its answer is conservation of energy states that energy cannot be created or destroyed, only transferred or transformed in a roller coaster. Potential energy at the highest point is converted into kinetic energy at the lowest point. As a roller coaster climbs higher, it gains potential energy, stored high energy due to its position when it descends. This potential energy is transformed into kinetic energy, energy of motion. However, some energy is always lost due to friction, air resistance, and other factors, leading to a slight decrease in total energy over time. Question number 3. Why do engineers use lubricants in machines and how does this relate to the concept of efficiency? Its answer is engineers use lubricants in machines to reduce friction between moving parts. Friction causes energy loss in the form of heat, which reduces efficiency. By reducing friction, lubricants help machines operate more smoothly and efficiently, conserving energy and reducing wear and tear on the machine's components. Question number 4. How do the principles of energy transfer apply to the process of heating water in an electric kettle? Its answer is in an electric kettle, electrical energy is converted into thermal energy to heat the water. When the kettle is plugged in, an electric current flows through a heating element. This element resists the flow of current, causing it to heat up. The heat from the element is then transferred to the water in contact with it. This process continues until the water reaches to its boiling point, at which point the thermal energy is used to convert the water into steam. Long questions. Question number 1. State and apply the principle of conservation of energy. Explain why perpetual motion machines are not feasible using the principle of energy conservation. Principle of conservation of energy. Energy can neither be created nor destroyed. It can only be transferred or transformed from one to another. Perpetual motion machines are not feasible. A perpetual motion machine would be a device that could operate indefinitely without an external energy source, violating the principle of energy conservation. For such a machine to function, it would need to continuously generate energy from within itself, which is impossible. Any energy produced would have to come from a stored source that would eventually be depleted, making the machine unsustainable. Additionally, all real world systems experience energy loss due to friction, air resistance, and other factors, further hindering the possibility of perpetual motion. Therefore, the principle of energy conservation fundamentally limits the feasibility of perpetual motion machines. Question number 2. Describe how useful energy can be obtained from natural resources, including fossil fuels, biofuels, hydroelectric resources, solar radiation, nuclear fuel, geothermal resources, wind, tides, and generator, where applicable. Its answer is obtaining useful energy from natural resources. Fossil fuels. Fossil fuels such as coal, oil, natural gas are the most commonly used energy sources. They are formed from the remains of ancient organisms and are burned to produce heat and electricity. Coal, burned in power plants to heat water, which produces steam to spin turbines and generate electricity. Oil, refined into gasoline, diesel, and other products for transportation and heating. Natural gas, used for cooking, heating, and generating electricity. Biofuels are derived from organic materials such as plants and animals. They are renewable energy sources and can be used as a substitute for fossil fuels. Ethanol, produced from corn, sugarcane, and other plants, and blended with gasoline to create a cleaner burning fuel. Biodiesel, made from vegetable oils and animal fats and can be used in diesel engines. Hydroelectric resources. Hydroelectric power is generated by harnessing the energy of flowing water. Dams create reservoirs that store water, which is then released to spin turbines and generate electricity. Solar radiation. Energy is captured from the sun's rays and converted into electricity to or heat. Solar photovoltaic cells. Solar photovoltaic cells convert sunlight directly into electricity. Solar thermal power use mirrors to concentrate sunlight to heat a fluid which produces steam to spin turbines. Nuclear fuel. Nuclear power is produced by harnessing the energy released from the splitting of atoms, nuclear fission. Nuclear reactors control the nuclear fission process to produce heat, which is used to boil water and create steam to spin turbines. Geothermal resources. Geothermal energy is obtained from the heat stored in the Earth's crust. Geothermal power plants use hot water or steam from underground reservoirs to spin turbines and generate electricity. Wind energy is captured by wind turbines, which convert the kinetic energy of the wind into electricity. Wind farms. Large groups of wind turbines are used to generate significant amount of electricity. Tides and waves. Tidal and wave power are generated by harnessing the energy of ocean tides and waves. Tidal power plants use the movement of tides to spin turbines and generate electricity. Wave power devices convert the motion of waves into electricity. In many cases, a boiler turbine and generator are used to convert the energy from natural resources into electricity. The boiler heats water to produce steam, which spins the turbines, and the turbine is connected to a generator that produces electricity. This process is common in power plants that use fossil fuels, nuclear fuel, geothermal resources, and hydroelectric power. Please like my video to motivate me. Let me know in the comment section which type of content you want regarding physics and maths. Don't forget to share it with your friends and subscribe my channel as well. Thank you.